Hey there, how's everybody doing? Happy Friday. Here's our algorithms for this morning. We got two, like usual. We have update inventory and trim. So let's go over update inventory first. We're going to be given an array of objects that represents new inventory. And also we'll be given an array of objects to represent current inventory. Our object is to update the quantities of the current inventory based on the new inventory. And if that item doesn't exist in the current inventory, then we will add it to the current inventory. When all is said and done, we'll return the current inventory after updating it. So for example, if this is our new inventory and this is our current inventory, this is what we expect to be returned. So you see, there is grain of rice in the new inventory and also grain of rice in current inventory. So we will add the new to the current to get 9,001. And likewise for peanut butter, that exists in the current inventory as well. So we'll add 50 to 20 to get 70. Now for royal jelly, that doesn't exist in the current inventory. So in that case, we need to add it to the return. We need to add it to the current inventory and then return it. And we could see that it will hold true as we go. If we get an empty array for the new inventory, and our current inventory is peanut butter quantity 20, then that's what we'll return. And for the last example here, if the new inventory, all we get is peanut butter, and our current inventory is empty, then we need to add that item to the current inventory and return it. So that's update inventory. For the second algorithm, we're recreating the built-in trim function in JavaScript. So the trim function will trim all of the spaces from the beginning of a string and from the end of a string, but leave all the middle spaces alone. Okay, and that's what we're going to do. We're going to be given a string that may have extra spaces at the start and the end, and return a new string that has the extra spaces at the start and the end trimmed or removed. We will not remove any other spaces. So any of these middle spaces, we will leave intact in our return. As you can see, if we were given this string with a bunch of start spaces and a bunch of end spaces, we will return the same string, but with no start or end spaces, and the middle spaces left alone. And that's trim. So go ahead and take about a half an hour or so. When you are ready, start this video back up. Good luck. All right, hope you did well on that. I'm sure you did. Let's go over how I solved it. I'll walk you through. So here's my solution here for update inventory. We're taking in the new inventory and the current inventory. So I've got a nested for loop here. So the outer for loop is to iterate through the new inventory. Okay, so I'm going to compare every item in the new inventory to every item in the current inventory. That's what my nested for loop is for, the current inventory. Okay, so for every item in the new inventory, I will check the current inventory items and see if the name matches. Okay. And I'm also going to set this flag. It's what we call these things, these flags that are Booleans. Because I want to know if I find that item in the new inventory. If I find that item in the new inventory right here, right? If the new inventory's name equals the current inventory's name, then I'll flag that as true. I'm going to flip that is present flag to true because I found that item in the current inventory. If I do find it, then I obviously want to update the current inventory's quantity and add the new inventory's quantity to that item in the current inventory. However, if I do not find that item in the current inventory, then is present will not be set to true. And I'll skip right on out of this for loop and go down here. So if it is not present, notice the exclamation point. We call this a bang, by the way, developer terms, the exclamation point. So if it is not present in the current inventory, then go ahead and push it right into the new inventory, right into the current inventory. And after that outer for loop is done, then I'll just go ahead and return the mutated current inventory. So here I am invoking the function, storing the return value in a variable called result, and then I'm just console logging that result. So let's start it with new inventory 1 and current inventory 1, which are these two lists of arrays of objects. And I'm supposed to get this back. So peanut butter 70, grain 9001, royal jelly 20. And let's go ahead and run that and see if that is the case. So I'll run that using node. That's right here. And there we go. We got an array with the quantities updated if those items exist in the current inventory. And if they do not exist in the current inventory, I'll just go ahead and add it. Okay. So take a look. I'll probably put some comments in here before I push this to GitHub so that you could take a look at what I did and see if you could understand it or improve it. Hopefully you can improve it. And we'll go ahead and move on over to trim, and I'll show you how I solved trim. So with trim, what I need to do is I need to find out where the first character starts and where the last character is, right? I want to find out that first character and the last character, meaning non-space. Okay, so I set up these two variables here so I could set where that first non-space character is and where that last non-space character is. That's what my first for loop is for. My first for loop, I'm just going from the beginning of the string to the end. And here's my condition. If the current character does not equal a space, then bang, I have found the index of my first character. I'll just go ahead and break out of that whole for loop. Okay, I found that the index of the first character. And then I'll do the same thing, but on the other side of the string. So I'll start from the end of the string right here and go to the beginning. That means I'm decrementing. Okay, if I'm decrementing, then I'm going towards the left. And then I'm just going to do the same thing. If I find the character that is not a space, then I will set that index, okay, not the character, the index to be the index of the last character. And then go ahead and break out of that for loop once I find that index of the last character. Once I find the first character index and the last character index, then all I got to do is start another for loop. And I'm going to start it at the first character index and end it at the last character index. and I'll just plus equal onto my trimmed variable right here. That's just an empty string. So I'll plus equal onto that trimmed empty string all the characters in the given string until I get to the last character index. Starting at the first character index to the last character index, and then just go ahead and return it when I'm done with that for loop. So here I am calling the function here, invoking the function, feeding it string 1, which is just this first test case, storing it in a value called result, and then console logging that result with a little label here, so I know what I'm looking at. And also I wanted to see the length. I wanted to see how long that result is, how many characters it has, because if I just console log it, then I can't tell if, well, I'll be able to tell if there aren't any leading spaces, but I won't be able to tell if there are any trailing spaces, because, you know, it's just this printout. I can't see if there are any spaces at the end of a variable or not, or at the end of a console log. So I also just want to double check if that length of the result is what I expect it to be. So I do expect it to be hello world, of course, but I also expect that length to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 characters. So let's give this a whirl. I just want to run trim.js. And there I go. Here's my trimmed string, and my length is 11. Just exactly what I expect. So again, with this one, I'll probably put some comments in here, trying to just sort of explain what every bit of code, what every chunk of code is doing, and hopefully you can improve on this one as well. It's not great, not a very efficient algorithm, because I could potentially have to iterate through the whole thing 3 times, right? That's crazy. That would be 3n, O of 3n. We'll talk about big O notation probably during your merge stack. So yeah, those are your algorithms for this morning. And I will see you whenever you like to start the morning lecture. I've also got that up linked on the calendar. So whenever you want to start that, go right ahead. Thanks.